In this video we're going to complete example 1. We're going to be sketching some quadratic functions. We're going to be completing 6 examples. On this page you can see question A. We're going to go all the way through to question E. You might notice that this quadratic function has been written in the form ax squared plus bx plus c. Now there's no number to the left of x squared, which means that technically we have the number 1 here. So we can see that a equals 1, b equals -2, and c equals -3. We'll make a note of that. A equals 1, b equals -2, and c equals -3. So the first thing we're going to look at is the direction of the parabola. We need to look at what a equals. A equals +1, and when it's a positive, it's going to be an upward facing parabola. So we'll make a little note to ourselves that it's an upward facing parabola because a is positive. The second thing we're going to look at is the y-intercept. Now the y-intercept occurs when x equals 0. So we're going to find f of 0, meaning we're going to replace x with the number 0. So up here we have x squared, which now becomes 0 squared. We then have -2x, which becomes -2 times 0, and then finally -3. Now whenever you multiply things by 0, they cancel out. So we're left with f of 0 equaling -3. That means when x is 0, y will equal -3. So we'll label that point here as 0, -3. This y-intercept could also have been found by simply looking at what c equals. C is -3, our y-intercept also occurs at -3. Alright, the third thing we got to look for are the x-intercepts. The x-intercepts occur when our function equals 0. So we're going to take this function, x squared minus 2x minus 3, and we're going to make it equal 0. We're now going to solve this for x, and we're going to do it by factorizing this expression. We're going to think to ourselves, what multiplies to make -3 and adds to make -2? Well, the two numbers I can think of are -3 and +1. -3 times 1 makes -3, and -3 plus 1 makes -2. That gives us the expression x minus 3 and x plus 1 equals 0. We simply took our two numbers, -3 and 1, and put it into our factorized expression. From this we'll get two solutions for x. X will be +3 and x will be -1. When we come up with our two solutions, we're looking at our sets of brackets and thinking what will make each set of brackets equal 0. For example, 3, well, 3 minus 3 is 0, and for -1, -1 plus 1 equals 0. It's also interesting to note that you get the opposite sign. We had -3, but a solution of +3. We had a +1 and a solution of -1. These are our two x-intercepts. So for the 3, we're going to label the point 3, 0. And for the -1, we're going to label the point -1, 0. Next, we need to find the axis of symmetry. The axis of symmetry occurs halfway between the two x-intercepts. It's going to be a dotted line like so, and we can see that it passes through the point where x equals 1. So the equation for our axis of symmetry will be x equals 1. We can see that this axis of symmetry is halfway between the two x-intercepts. The last thing we need to find is the vertex. The vertex will land on the axis of symmetry, which means it occurs where x equals 1. So what we need to do is take the original function and replace x with 1. We have x squared, which now becomes 1 squared. We have minus 2x, which becomes minus 2 times 1. And then we have minus 3 at the end. Now when we work this out, we get 1 squared, which is 1. So 1 minus 2 minus 3, which will give us negative 4. So when x is 1, y will be negative 4. We'll label that point here. When x is 1, y will be negative 4. We now have all the points we need to sketch our parabola. You'll notice that our parabola passes through our two x-intercepts, our y-intercept, that our turning point exists at the vertex, and that it's an upward facing parabola, which we mentioned at the beginning. I just want to point out that this should only be a quick sketch. I only labeled my key points. Some people spend too much time labeling all the points on the x-axis and all the points on the y-axis, and you don't really need to do that. Anyway, let's now move on to question B. Now the first thing you might notice is that our function is not in the form ax squared plus bx plus c. If that's the case, it's usually better just to expand the brackets first. We have the difference of two squares here, which means we simply square the x's. So x times x gives us x squared, and then square the 3's. 3 times 3 will give us 9. And because it's the difference of two squares, there's going to be a minus sign between them. Now this can throw people sometimes because it still looks like it's not in the form ax squared plus bx plus c. But it technically is, and to help you see what's going on here, I'm going to move the minus 9 a bit further to the right. So what's happening in the middle here? Well, technically we have plus 0x. So it's x squared plus 0x minus 9, and 0x just cancels, which is why we write down x squared minus 9. That means that a equals 1, because technically there's a 1 to the left of x squared. B equals 0, because there's nothing in the middle. And C equals negative 9. So the first thing we look at is the direction of the parabola. And we can see that A is positive. It's positive 1, which means that we're going to have an upward facing parabola. The second thing we're going to look at is the y-intercept. Now we can take a quick shortcut here and just look at what C equals. C equals negative 9. So we're going to label a point about here. That's going to be our y-intercept, and we'll write this as the point 0, negative 9. The third thing we're going to look at are our x-intercepts. And the x-intercepts occur when we make the function equal 0. Now we actually have the function in two different forms. It's always best to take the function in the factorized form. So we'll take x plus 3, x minus 3, and make this function equal 0. We can see that we're going to get solutions of negative 3 for x and also positive 3. That's because negative 3 plus 3 is 0, and positive 3 minus 3 also equals 0. So we'll label those 2 points on our graph. We've got the point 3, 0, and the point negative 3, 0. The fourth thing we need is the axis of symmetry. So we look at our x-intercepts and think to ourselves, what's halfway between these 2 points? And our axis of symmetry is actually going to go over the y-axis, like so. So the equation for that would be x equals 0. The last thing we need to find is the vertex. Now we know that the vertex lies on the axis of symmetry, and it's actually already been found because when x equals 0, y equals negative 9. So our vertex is the same point as the y-intercept. So we'll write that down. Our vertex is 0, negative 9, and we probably should have written down for our y-intercept 0, negative 9 as well. Now because our vertex and our y-intercept are the same, we have only 3 points this time. But we can still sketch our parabola. 3 points is enough. We just need to make sure that our turning point occurs at the vertex and that it's an upward facing parabola as well, and also that it passes through the x-intercepts. Alright, let's now move on to question C. Once again, it doesn't look like it's in the right form. We want it to be ax squared plus bx plus c. So we've got to swap things around a little bit. We'll start by moving the negative x squared to the beginning. Negative x squared. And this is positive 3x. So we're going to write plus 3x. So this is what f of x equals. So we need to figure out what a equals, what b equals, and what c equals. So to the left of the x squared, we have the negative symbol. This is technically negative 1 x squared, so a equals negative 1. We can see that b equals 3 because 3 is to the left of the x, and there's nothing here for c, which just tells me that c must equal 0. So the first thing we're going to ask ourselves is, what is the direction of the parabola? And we can see that we've got a negative value for a, which means that it's a downward facing parabola. The second thing we're going to look at is the y-intercept. It's easy to find the y-intercept by simply looking at what c equals. C equals 0, so our graph is going to cut the y-axis at 0. So we'll write down this point, 0, 0, this is the y-intercept, and we'll also write it down here at the left. So the third thing we're going to find are the x-intercepts. To do this, I need to factorize either one of my functions here. I think it's going to be easier if I take the first function. I'm going to get x bracket 3 minus x. X times 3 is 3x, and x times minus x gives me minus x squared. Now I've just realized I should have made my function equal 0, so I'm going to change this so that it equals 0. I'm going to get two solutions here. Either x will equal 0 or x will equal 3. If I substitute 3 into this set of brackets, I get 3 minus 3, which is 0. And here I've got x on its own, so if I substitute 0 in place of x, I get 0 again. That means I'm going to have x-intercepts at 0 and 3. I've already got an x-intercept labeled here, so I just need to label the second one at the point 3, 0. We can see that one of our x-intercepts are the same as our y-intercept. The next thing we need to find is the axis of symmetry. The axis of symmetry will always occur halfway between our two x-intercepts, so our equation will be x equals 1.5. We'll also write that under step 4, that x will equal 1.5 for our axis of symmetry. And finally, we need to find our vertex. We know that the vertex has the same x value as the axis of symmetry, so we simply need to substitute this x value into our function. So what are we going to get? We have 3x, that becomes 3 times 1.5, and then we have minus x squared. So we get minus 1.5 squared. I think I'm going to use the calculator for this one. So we have 3 times 1.5, 3 times 1.5, minus 1.5 squared, which will equal 2.25. Which means that our vertex exists at the point 1.5, 2.25. We know that this is a downward facing parabola, so we're going to sketch a downward facing parabola like so. It's very important that our turning point occurs at the vertex and that our parabola passes through our two x-intercepts. Alright, we'll move on to question D now. This function has been written in the form ax squared plus bx plus c. So we can see that a is 2, b is 6, and c is negative 8. So the first thing we're going to look at is the direction of the parabola, and we can see that it's an upward facing parabola because A is positive. A is positive 2. Finding the y-intercept is also going to be really easy because we just need to look at our C value. C equals -8. So our graph will intercept the y-axis at this point here, where x is 0 and y is -8. Next, we need to find our x-intercepts. We calculate these by taking our function 2x squared plus 6x minus 8 and making it equal 0. I'm going to factorize my expression over here, and the first thing I'm going to do is take out a factor of 2. It becomes 2 times x squared plus 3x minus 4 equal to 0. 2 times x squared is 2x squared, 2 times 3x is 6x, and 2 times minus 4 gives us minus 8. We're looking to factorize what's inside the brackets. We need two numbers that multiply to make -4 and add to make positive 3. And the two numbers I'm thinking of are positive 4 and -1. 4 times -1 is -4. 4 minus 1 gives me positive 3. That means I'm going to get two sets of brackets, one with a positive 4 and one with a -1. This will equal 0, and I need to put a 2 to the left of these brackets. Now, when you find solutions to a function like this, the 2 is actually irrelevant. The answers we're going to get are -4 and positive 1. And that's because -4 is the opposite to positive 4, and positive 1 is the opposite to -1. So I'm going to label my two x-intercepts as 1, 0, and also -4, 0. The next thing I need to find is the axis of symmetry. This will occur halfway between my two x-intercepts. Now, sometimes it's not completely obvious where the halfway point is. When you get in situations like that, you simply take your two numbers, -4 and 1, and you add them together. So -4 plus 1, I'm going to add them together. So I'll put brackets around to show that I'm adding first, and then divide them by 2. We'll use our calculator. Bracket, -4 plus 1, close the bracket, dividing it by 2, and we get -1.5. So our axis of symmetry will pass through this point here, where x equals -1.5. The last thing we need to find is our vertex. To find the vertex, we simply take our x value from our axis of symmetry and substitute that into our function. So we're trying to find f of -1.5. We know the first part of our function says 2x squared, so we're going to write this as 2 times -1.5 squared. We then have plus 6x. We're going to write that down as plus 6 times -1.5. And finally, minus 8. We write that at the end. Let's work this all out on the calculator. 2 times -1.5 squared plus 6 times -1.5 minus 8 equals, and we get -12.5. Alright, so our vertex must exist at this point here, which is the point where x is -1.5 and y is -12.5. Now we have enough information to draw our parabola, making sure that it passes through the two x-intercepts as well as the y-intercept, and making sure that the turning point occurs at the vertex. Alright, let's now move on to question E. So here we have our function in the form ax squared plus bx plus c. Looking at A, there's no number here. That's technically -1. So A must equal -1. We can see that B equals -4. And C also equals -4. So the first thing we're looking at is the direction of the parabola. And this is going to be a downward facing parabola. And the reason for that is because A is negative. It's -1. The second thing we're looking at is the y-intercept. And to find the y-intercept, we simply look at what C equals. C equals -4. So the y-intercept will occur where x is 0 and y is -4. We'll also label that over here on the graph, 0, -4. The next thing we're looking for are the x-intercepts. We need to take our function, -x² minus 4x minus 4, and make it equal 0. We now need to factorize the expression on the left. I'm going to start by factoring out the negative. So I'm going to put a negative to the left of the brackets, and now everything becomes positive. And I can see that because whenever I apply this negative to each term inside the brackets, they all become negative. So I'm just focusing on what's inside the brackets. What two numbers multiply to make +4 and add to make +4? The two numbers I'm going to get are +2 and +2. Both the same. 2 plus 2 is 4 and 2 times 2 is 4. That means I'm going to get two sets of brackets and they're both going to have +2 inside of them. Now to find my solutions, I just look at my brackets and try to make them equal 0. And we can see that that will occur when we make x equal -2. And that's the same for both sets of brackets. So technically we're only getting one solution because this one solution can be used for each set of brackets. So on our graph, this is the point where we have our x-intercept. It's the point -2, 0. So now we need to find our axis of symmetry. Now the axis of symmetry is always halfway between the two x-intercepts, but this time we only have one x-intercept. What do you do in this scenario? Well, when there's only one x-intercept, the axis of symmetry actually goes over this point. So the axis of symmetry has the equation x equals -2. This is because the axis of symmetry goes over the x-intercept. What about the vertex? What is the vertex? Well, we know that when x equals -2, we get a y value of 0, and that's because we've already labeled this point. The x-intercept will also be the vertex. The vertex is -2, 0. So whenever you only get one x-intercept, you will find that this will also be the vertex and also be the point at which the axis of symmetry passes over. So how do we draw a parabola with only 2 points? Well, we know that this point here is the turning point. This is the vertex. We also know that it's a downward facing parabola. So I know it's going to do something like this and come down. Now you might remember that parabolas are always symmetrical on both sides of the axis of symmetry. We have a point here which is 2 squares from the axis of symmetry, which means there should be another point 2 squares from the axis of symmetry on the other side. That helps us. It gives us a third point so we can finish our parabola like so. Alright, let's now move on to question F. We have ax squared plus bx plus c. We can see that a is +2, b is +5, and c is -3. So the first thing we're looking at is the direction of our parabola. It's an upward facing parabola because a is positive. A is positive 2. Next, we're looking at the y-intercept. We can see that c equals -3, so our y-intercept will occur at 0, -3. I'm going to label that on my graph here. It's the point 0, -3. Some of you may be wondering why I've put the point here when I could put it 1, 2, 3 squares down. The main reason I'm doing this is because I know the vertex is going to be below this point, so I need a bit of room for my vertex. So I'm counting each square as 2. So we're going -2, -4, and -3 must be halfway between these 2 points. Alright, the next thing we need to find are the x-intercepts. So we need to make our function equal 0. This time I can't factor out the 2, which means we're factorizing a non-monic quadratic, which is quite challenging. We'll start by multiplying our outside numbers. 2 times -3 gives us -6. We then look at the number in the middle, which is +5, so we have -6 and +5. We're looking for 2 numbers that multiply to make -6 and add to make +5. The 2 numbers I can think of are +6 and -1. Because 6 when added to -1 makes +5, and 6 when multiplied by -1 makes -6. So what do we do with these 2 numbers in green? Well, we're going to take the middle term, the 5x, and split it. We're going to split it into 6x minus 1x. That comes from our 2 numbers, 6 and -1. Now 6x minus 1x is the same as 5x, so we haven't actually changed the function, we've just made it a bit longer. Alright, where to from here? We're going to factorize the first 2 terms, and then we'll factorize the last 2 terms. So when I factor the first 2 terms, I'm going to have 2x to the left of the brackets, and then I'm going to have x plus 3 inside the brackets. 2x times x is 2x squared, and 2x times 3 is positive 6x. Looking at the next 2 terms, I'm going to put -1 in front of the brackets, and then x plus 3 inside the brackets. -1 times x is -1x, and -1 times 3 is -3. We can see that both sets of brackets are the same, which is what we want. And we've got 2x minus 1 outside the brackets. So we go 2x minus 1, and then our second set of brackets will be x plus 3, exactly the same as what we had in the brackets before. And this will equal 0. If you struggled with what I've just shown you, this is something we covered in a previous topic, and it was about factorizing non-monic quadratics. Alright, we're looking at each set of brackets and we're trying to figure out how to make each set equal 0. There's one that's really obvious at the moment. X equals -3, because -3 plus 3 is 0. But what about the first set of brackets? How do you make 2x minus 1 equals 0? Well, sometimes you have to solve it. So we'll write that here. 2x minus 1 equals 0. So we're going to add 1 to both sides, giving us 2x equals 1, and then we're going to divide both sides by 2, and we find that x equals 1/2, and I'll write that as a decimal. X equals 0.5. So our 2 solutions are x equals -3 and x equals 0.5. I'll put them on the graph. Here we've got the point where x is -3. This is -3, 0. And we also have the point 0.5, 0. You might notice when looking at the x-axis, I've counted each square as 1. -1, -2, -3. But for my y-axis, I counted each square as 2. Now, if you're wondering why I've done this, it's purely just to make it easier for me to fit the curve on the xy plane. It's better to have the same scale for both the x and the y axis, but sometimes you get into situations where you just can't do that. Anyway, let's now find the axis of symmetry. The axis of symmetry occurs halfway between the two x-intercepts. So probably the easiest way to do this is just to add them up. So we had -3 and 0.5 and then divide them by 2. I'm going to grab my calculator for this. -3 plus 0.5. Now I actually had that in brackets, so I need to press equals before dividing it by 2. So divide 2 gives me -1.25 equals -1.25. I'm going to draw my axis of symmetry, which is slightly to the left of -1, like so. So I have x equals -1.25. Finally, I need to find my vertex. To find my vertex, I simply substitute the x value I got for my axis of symmetry, -1.25, into the function. So we're going to get 2 times -1.25 squared plus 5 times -1.25 minus 3. And I think this is one for the calculator. All right, 2 times -1.25 squared plus 5 times -1.25 minus 3, and we get -6.125. -6.125, which means that our vertex is going to occur about at this point here, which is where x is -1.25 and y is -6.125. Now we can do a quick sketch of our parabola, making sure it turns at the vertex and making sure it passes through our x-intercepts and our y-intercept. Anyway, that concludes our video on example 1. Remember to read the description below for links to workbooklets that relate to this video.